This is section 5.03 of Unit 5 Notes, Probability. Today I am, as in you are the student, discussing probability so that I can calculate theoretical and experimental probability. I will know I have when I can successfully solve probability problems. The specific text we're looking at for today's lesson is 8b. Probability. The probability of an event describes how likely the event will occur. Probabilities will always be between 0 and 1, or in the percentage form, 0% to 100%. With 0 meaning it's impossible, it will never happen if it's an absolute 0. Or 1 meaning 100%, it's for sure going to happen. I can guarantee no matter what you say that said probability, said thing will occur. Now, simple probability. Probability in terms of math is the amount of favorable outcomes divided by the total amount of outcomes. So for this example that we're seeing right here, let me cover some of these things up and then reveal them as we go. So for example, let's say I want you to find the probability of choosing a red marble from a bag of red and blue marbles. Excuse me. Let's say from this bag of marbles, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total marbles. And then I want to figure out what's the probability that I will choose red. So you count up the red marbles, 1, 2, 3, 4, 5, 6, 7. And the probability that I will choose a red marble is 7 out of 12. Okay, if you want to change that into its percent, take 7 divided by 12, multiply by 100, and this says it's about 58.3% that you will choose a red marble from a bag of red and blue marbles out of a total of 12. So 7 out of 12 will be red, or in percent, 58.3%. Now, same thing with blue. You count up the total amount of marbles and then you only pick the blue ones. Well, blue, we have 1, 2, 3, 4, 5 out of 12. And so the probability that you will pick blue is 5 out of 12. In terms of a percentage, 5 divided by 12 times 100. And we say that there's about 41.7% chance that when you pick a marble, it will be a blue marble. Or, as a fraction, 5 out of 12 times you'll pick a blue marble. Same thing with red. 7 out of 12 times you will pick a red marble. So, that is simple probability. So when finding probability, first step you want to do is find the number of the desired outcome. How many are you choosing? How many are you wanting out of the event for a certain specific thing or item or object or whatever? Step 2, find the total number of possible outcomes for said object, said item, etc. And then step 3, create a fraction using the two values. Don't forget to reduce the fraction if possible. So here's an example. And again, I'm going to cover these up so that the example doesn't get spoiled as we go. Although it's already been spoiled. I'm going to pretend you didn't see that. What is the probability of flipping a coin and having it land on heads? So how do we find the fraction? How do we find the probability of flipping a coin and having it land on heads? Well, here's what you have to ask yourself. Step 1, find the number of sides of the coin with heads. Now, if you typically have a coin, there are two sides to every coin. You have heads and then you have tails is what we call it. Heads because there's a face, tails being the other end of it. So, how many sides of the coin will have heads? In this example, 1. One coin has a head. Now, step 2. Find the total number of sides of a coin. So on the coin, we have two sides, the heads and the tails. So we have 2. Step 3, create a fraction using the 2 values. Don't forget to reduce if possible. So again, the fraction is the desired outcome, which is the number of heads, divided by the total possible outcomes, which is the total amount of sides we have in a coin, which then translates to 1/2. Now, if you want to check to see if this reduces any further, there's a couple ways you can do that. You could type in the fraction 1 divided by 2 into Desmos, and then click the circle with the fraction symbol right there, and have it reduce the fraction if possible. It gave me back 1/2, which means it is already in its lowest terms, so 1/2 is the final answer. Now, on not Desmos, on TI-84, you would type in the fraction, 1 divided by 2, press math, enter, enter, and then have it reduce the fraction from there. And again, it does not reduce any further. It just gave me back the fraction that I entered. So 1/2 is the final reduced answer. Okay, another example. Except if we were in class, we would do this together. But since this is a video, I'm just gonna go through it with y'all. What is the probability of spinning the arrow on a spinner and having it land on the 4? So we have a picture of a spinner right here. And on the spinner, you have 1, 4, 3, 4, 4, 2. You have 6 individual slices with certain numbers being repeated. And we want to figure out what the probability of landing on a 4 is. So step 1, find the number of spaces with the number 4. I count, let me use a different color there. I count 1, 2, 3 different spaces with the number 4. Therefore, 3 is step 1. We have 3 spaces with the number 4. How many total spaces do we have on the spinner? Well, if I count all the total slices, 1, 2, 3, 4, 5, 6, we have 6 total slices, spaces, whatever you want to call them. Now we're going to create a fraction using the 2 values, and don't forget to reduce if possible. So again, the fraction is the desired outcome, the number of desired outcomes, which in this case is the number of spaces with the number 4, divided by the total number of possible outcomes, which in this case is the total number of spaces on the spinner, 6. So now, 3 divided by 6 is what we initially have. And then let's check to see if it'll reduce further into a more simplified fraction. So I'm going to type in on the TI-84, 3 divided by 6, math, enter, enter. And it gives me a reduced fraction of 1/2. Okay, so 3 divided by 6 and 1 divided by 2, as you can see, are the exact same fraction. It's just sometimes we want a simplified fraction to not get bogged down with bigger numbers. So 1/2 is the correct simplified answer. And then on Desmos, do the same thing. 3 divided by 6, click the fraction bubble, and then it'll reduce it to 1/2. That's it for this example. Okay, you try number 1. What is the probability of rolling a 3 on a 6-sided number die? Step 1, find the number of sides with the number 3. Now I've laid out the die for you to count how many 3s there are. Step 2, find the total number of sides on a dice, or die, I think. Step 3, create a fraction using the 2 values, and then don't forget to reduce if possible. And then there you will get your final answer. Now bonus, what is the probability as a decimal? Round your answer to the nearest 100th or 2 decimal places. And then you can move these boxes if you're on ClassKick to check your work and see if you're doing everything correctly. So at this time, I would like for y'all to pause this video and try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So find the number of sides with the number of 3. Well, with the number 3. And then as you look on a die, there's only one space with 3 on it. And so we have 1. Find the total number of sides on a die. We have 1, 2, 3, 4, 5, 6 sides to a die, to a cube. So 6 is the total. Make a fraction from those two with the number of outcomes divided by the total amount of outcomes. 1 divided by 6. P3 states probability of choosing a 3 in this scenario, equals 1 over 6. Now, plug it into the calculator just to check yourself and see if it'll reduce. 1 divided by 6. Math, enter, enter, and then it gave me back 1 over 6. So it's already in reduced form. Same thing with Desmos. Type in 1 divided by 6. And then if the bubble thing was not clicked, make sure you click it. And it shows me a reduced fraction. Now, if you wanted to try the bonus, what is the probability as a decimal? Round your answer to 2 decimal places. I'm going to divide these, 1 divided by 6, enter, and then I'm going to choose these two, the first 2 decimal points, and then using the next one to round the 6. Now, the next number, which is also a 6, will make the rounded 6 round up. So anything that's 5 or bigger will make the number round up. Anything that's less than 5 will round the number down. So because it's bigger than 5 or 5 or bigger, then this will be 0.17 as my decimal answer. So the decimal answer for probability is 0.17. And that's it for you try number 1. So what we just went through was called theoretical probability. Theoretical probability is based on what should happen. You're going to use the formula to find the answer, and you're going to base your guess on what should happen. However, not everything happens as it should. Sometimes when you're flipping a coin, it doesn't always land on heads. It sometimes lands on tails. Sometimes when you're rolling a die for the number 3, sometimes you're never going to get the number 3. And you'll get everything else except the number 3. And so that's what's called the experimental probability, which is based on what has happened, on what actually happens. Theoretically, you should be able to roll a 3 1 out of 6 times you roll the die. But maybe it takes you 10 times to roll the 3 versus 6. Again, that is the experiment. That is the experimental probability versus what theoretically should happen. Experimental probability, you perform the experiment and the results are the answer. Okay? So let's go through a couple examples here. So let's talk about first theoretical probability, which is something we've already went through, but now we're going to do this in terms of in terms of theoretical and experimental, now knowing what each one of these are. Okay, so we're going to look at theoretical probability first and then talk about experimental. So theoretical probability of an event: 11 tiles lettered Probabilit and Y are lying face down on a table. One tile is selected, the letter is recorded, the tile is replaced, and then the process is repeated. Meaning you have a bag of letters, you pick one, you write it down to say what you have, and then you put it back in the bag and then perform the probability, the experiment, or whatever it is again. So theoretically, what is the theoretical probability of selecting the letter B? So first, we need to figure out how many tiles have the letter B. And if we look through the word probability, there are 2 B's. So that's the amount of desired outcomes. How many total do we have? If you count out the letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 tiles altogether, with 2 of them being B's. So the probability of choosing the letter B from these tiles is 2 out of 11. 2 out of 11. And again, if you want to figure out the different ways of representing probability, 2 divided by 11, probability can be expressed as a decimal. So the decimal, if we round to 2 decimal places, is 0.18. That is the probability as a decimal. Let's say I want a percentage. Multiplied by 100, and 18% or 18.2%, depending on where you round, is the probability that I will choose a B from these tiled letters. Just showing y'all a different way to think about probability, because it's not always fractions. It's fractions, decimals, and percentages. Those all can represent probability, and you have to understand when to use or what represents which in the scenario. Okay, so same problem, except you try number 2. I'm going to ask y'all to choose a specific letter, or a different letter. What is the theoretical probability of selecting the letter L? So fill out the formula, look for the letter L, and tell me what the probability is as a fraction for you try number 2. Go ahead and pause the video. Try this on your own. Excuse me. Otherwise, I'm going to continue on and show y'all how to do this. So again, step 1. How many desired outcomes do we have? We're choosing the letter L. If we look through, we only have 1 letter L. So there's 1 out of the 11 tiles that we counted. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1 out of 11. And that's it. That's it. That's your fraction. That's your probability, your final answer. 1 out of 11, which is 0.09 as a decimal, and as a percent, 9% of the time, you're going to choose the letter L from 11 tiles that you're picking randomly. That's it for you try number 2. Okay, still talking about theoretical probability. The graph shows the number of each kind of book in the hero's personal library. If a book is chosen at random, what is the probability that the book is a science fiction book? So again, we're choosing something at random. What should happen when we do that? And in this case, what should the probability be that we choose a science fiction book? So this example is another one that we would normally do in class, but since this is a video, I'm going to go ahead and go through it. Find the number of science fiction books. Step 1. Looking through, I have science fiction, romance, biography, and adventure. Science fiction says there's 14 books in Heroes Library that are science fiction. So 14 is my desired outcome. Find the total number of books. We're going to have to do a little bit of math here. We're going to need to add all of these together. 14 plus 2 plus 4 plus 10 gives me a total of 30. So there are 30 books that can be chosen from. Now, create a fraction using the 2 values. Don't forget to reduce if possible. The probability of choosing a science fiction book is 14 over 30, the amount the total amount that we want to choose, and then the 30 being the total amount, period. 14 is what we're choosing. 30 is the total, period. Now we're going to plug this into the calculator, determine whether if it can be reduced or not. So 14 divided by 30, math, enter, enter. And it can reduce to a more simplified fraction form of 7 over 15. Same thing if you want to apply this, do this using Desmos. 14 divided by 30. Press the fraction circle symbol, and we get a reduced fraction of 7 divided by 15. 7 over 15. So final answer, 7 over 15. Okay, you try number 3. Same graph as before. So, again, if a book is chosen at random, what is the probability that the book is an adventure book? Find the number of adventure books, step 1, from the pie chart that you see over there on the right. Step 2, find the total number of books. So you're going to have to add those all up to get your total. Step 3, create a fraction using the two values. Don't forget to reduce if possible. So step 1 and 2, you're going to apply those together to create the fraction and then put your final answer in fraction form. And then a bonus. What is the probability as a percent? Round your percent answer to the nearest whole number. So go ahead, pause the video, try this out on your own, see if you can figure it out, and then use these boxes right here to check your answer and make sure you're doing all your steps correctly. Otherwise, I'm going to continue on and show y'all how to do this. So, find the number of adventure books, 10. I have 10 adventure books, or Hero has 10 adventure books in his personal library. Total amount is to add 10, 14, 2, and 4. We've already done this in the previous problem, so I don't need to exactly show it to y'all, but this is going to be 30. 10 out of 30. Well, 10 out of 30 is what we're going to be using for step 3. So create a fraction using the two values. Don't forget to reduce if possible. The probability of choosing an adventure book is 10 out of 30 if we were to choose a book at random. Which, if we were to reduce 10 divided by 30, math, enter, enter, is 1 over 3. Same thing if we input this into Desmos, 10 divided by 30, with this little bubble highlighted, 1 over 3. Now, what is the probability as a percent? So this is where I would type in 1 divided by 3, get the decimal answer, and then multiply by 100 to get the percent answer. I want to round my percent answer to the nearest whole number. So that means no decimals. I'm going to stop at the decimal and then round this 3 up or down where applicable. So looking at the next number, it is less than 5.3, which means this 3 will round down and stay the same. So 33%. Don't forget the percent symbol. Will be an adventure book if it gets chosen at random. And that's it for you try number 3. Okay, so what we just talked about was all theoretical probability. And in a sense, some of this can be applied theoretically. However, there is an experiment component to it, but we'll talk about it a little bit later, or in a little bit. So, theoretical probability. Again, it's what should happen when performing the experiment. So, when we flip a coin and we choose heads, 1 out of every 2 tries we should get heads, meaning 50% of the time or half the time we should land on heads. However, let's say we perform the experiment and we recorded every single performance. Using experimental probability, we record the results of flipping the coin, then calculate the probability. So in this scenario, let's say we flip a coin and we noticed when we looked at it, 3 of the times heads came up, and then 1 of the time tails came up. And so from the experiment, 3 out of a total of 4 trials actually came up as heads, meaning 75% the probability came out to be heads. That's experimental. Experimental shows us the probability of what occurred, not what should happen. Theoretically, we should have 50% probability, or 1/2. But in the experiment, we did the experiment 4 times, and we found out that 3 out of the 4 tries were heads, meaning 75% of the time the experiment turned out to be heads versus 50% of the time, theoretically. So that's the difference between theoretical and experimental. It's going to be the same as before. We're still going to find the number of times for the desired event, how many times it's occurred. Step 2, we're going to find the total number of trials, and then step 3, we're going to create a fraction using the 2 values, and then don't forget to reduce the fraction if possible. But notice the wording in these examples here. The previous is at random what we're choosing, if we were to choose. Again, if. The experiment has already happened. And so we're just taking the data and determining what the data tells us about probabilities. So let's look at this example. The bar graph shows the number of spins that landed on the colors red, blue, green, yellow, and purple. According to the bar graph, what is the experimental probability that the spinner lands on purple? So what happened? What happened in this experiment with purple is what it's asking. So step 1, find the number of times purple occurs. Let's look at purple, and we see that purple occurred twice. Find the total number of colors. Well, total number is red plus blue plus green plus yellow plus purple. So that's 1 plus 4 plus 2 plus 3 plus 2 from what each bar value represents, which totals up to be 12. There are a total of 12 trials in this experiment. Now create a fraction using the 2 values. Don't forget to reduce if possible. So number of times that you spin on purple versus the total number of times. 2 out of the 12 times it landed on purple. Type it into your calculator to determine if it reduces. 2 divided by 12. Math, enter. 1 out of 6. Or if you use Desmos, 2 divided by 12, click the little circle, and we get the same answer, 1 divided by 6. Which means our reduced probability for this experiment is 1 out of 6. 1 out of 6. And theoretically, there are 5 colors. 1, 2, 3, 4, 5. Theoretically, purple, its theoretical probability would have been 1 out of 5, 1 over 5. But experimentally, we had 1 out of 6. So again, theoretical versus reality. Theoretical versus reality. You try number 4. Same bar graph, except now, according to the bar graph, what is the experimental probability that the spinner lands on blue? Find the number of times blue occurs. That's step 1. Find the total number of colors. Step 2. Total number of colors in the experiment, not just colors in general. 3. Create a fraction using the 2 values. Don't forget to reduce if possible. So divide them and then get a simplified fraction from your calculator. And then, of course, if you're using ClassKick, don't forget to move these boxes to check your work and see if you're performing the steps correctly. Bonus, what is the probability as a decimal? Round your answer to the nearest hundredth, meaning 2 decimal places. So for the you try number 4, go ahead and pause this video. Try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So step 1, find the number of times blue occurs. Blue occurs about 4 different times. So step 1, answer is 4. Step 2, find the total number of colors. Again, we're not counting 1, 2, 3, 4, 5 different colors. We're counting the amount of trials. Number of colors, trials. So that's 1 plus 4 plus 2 plus 3 plus 2. Which we said before was 12. So 4, 12. 4 out of 12. Create a fraction. So we're going to do 4 out of 12. We're going to check to see if it reduces on the calculator. 4 divided by 12. Math, enter, enter. And it'll reduce to 1/3. And if you want to use Desmos, just type it in. Make sure this little bubble is clicked for the fraction. 1/3 is our reduced form. They mean the same thing. 4 divided by 12 is the exact same as 1 divided by 3. It just looks a little cleaner. That's it. Bonus answer. What is the decimal form? And then round it to 2 decimal places. So rounding it to 2 decimal places, we're going to cut it off right here where the mouse is at. It'll round down because the number right next to it is less than 5. So the final answer for the bonus is 0.33. And that's it for you try number 4. All right. Probability of complementary events. One of the 2 events must occur, and the outcomes in each event do not overlap. Combining all the possible outcomes of both events results in all the possible outcomes of the experiment. So, meaning the sum of the probability of the complementary event is always 1. So, what do I mean by complementary? So, if something goes in, it has to also come out. If there are even numbers, then that means there are odd numbers. Only those 2. If you win, then you also there's also the chance of losing as well. There are 4 different directions. You can go north, you can go south, you can go east, you can go west. Those are all complementary. The probabilities will show to be complementary. If you go, better way to say the north-south thing is if you go north, well, you could also go south. If you go east, well, then you could also go west. Each event has a complementary opposite event. So, what do I mean by this? In this example, we have a spinner. We have the colors red, green, orange, blue, and yellow. Spinning a red and not spinning red are complementary events. So what's the probability of spinning a red? Well, there's 1 red out of 5 different colors. So we have 1 out of 5 chances of spinning red. What if I want to spin not red? What's the probability of not spinning a red color? Well, besides the 1 red, there are 1, 2, 3, 4 other colors that are not red. And so I have 4 out of 5 chances of not spinning red. Again, notice 1 out of 5 is red. 4 out of 5 is not red. When you add those two together, 1 over 5 plus 4 over 5, which equals 5 over 5, and is 1, equal to 1. When you add complementary events and they equal to 1, then they are truly complementary. It should pan out that when you add those two together, the sum of the complementary events is always 1. That's how you know they are complementary. Now, another way we can find out what the complementary is without doing the second part of counting up the not reds is by subtracting it from 1. Subtracting whatever current event we have and subtracting the current event from 1 to get its complementary event. Here's what I mean. Because the sum of complementary events is 1, if you know the probability of an event, then you can find the probability of its complement just by subtracting it from 1. Here's the formula. P probability of not A, this reads as not A, or A prime, not A, equals 1 divided by the probability of A. A, in this case, is spinning red. So, if I want to figure out what the probability of not spinning red is, I simply subtract the probability of spinning red from 1 and then get the fraction. So, for example, the probability of spinning red is 1 over 5. To get the opposite of not spinning red, I'm going to take 1 minus whatever that probability was, 1 over 5. I'm going to get a decimal, but let's say I want the fraction. I'm going to press math, enter, enter. Or if you use Desmos, just click the little circle with the fraction symbols. And you will get the opposite of the complementary of the probability of red, which is 4 out of 5. 4 out of 5 is not red. And that's it. That's the complementary probability. When you add those two together as a check, 1 divided by 5 plus 4 divided by 5, it should equal 1. If they do, then you know for sure that these are complementary events. Okay, here's an example. If the probability of winning a raffle is 0.002, what is the probability of losing? So, losing is the complement of winning, or the opposite. So, how do I find the probability of losing if I know the probability of winning? Well, since these are complementary events, I'm just going to subtract the winning probability from 1. So I'm going to take 1 and subtract 0.002. I'm going to get 0.998. So the probability of losing is 0.998. If you want to turn that into a percentage, losing is 99.8% of a chance. Or the probability of losing is 99.8%. In decimal form, it's 0.998. So, that's that example. You try number 5. The probability that it will rain is 42%. What is the probability that it will not rain? So, again, not rain is the complement of raining. So, since these are complements, all we got to do is take 1 and subtract our probability from the word problem. Now, this is 42%. When doing math, you typically want to, more often than not, change the percent symbol into its decimal form. So, change it back to its decimal means you need to divide it by 100. Change its percent value to its decimal form. Do the math, And then let's change it back to its percent answer by multiplying it by 100, whatever your decimal answer is. Okay. If you want to check your work, there's a box underneath it for you to do so. So feel free to do that if you're working through these things in ClassKick. You try number 5. Go ahead and try this on your own. Pause the video, see if you can figure it out. Otherwise, I'm going to continue on, show you all how to do this. So 42% as a decimal. You're going to take 42 divided by 100, and you get 0.42. Do the math. 1 minus 0.42. And we have 0.58. I want the percent form. So take your answer, multiply by 100. And we have 58%. So 42% it will rain, but then there's also 58% chance that it will not rain in the area. Another way you can do this, because this does involve percentages, one, you could change to a percent by just doing 100, changing it to 100, and then subtracting the percent from there. So 100 minus 42, you'll get the exact same thing. Either way, you'll get the right answer. That's it for you try number 5. Okay, one final thing before we end the notes. Law of large numbers. So the more trials you do in an experiment, the closer the calculation for the experimental probability will be to the theoretical probability calculation. What does that mean? The more trials you do, the closer it will be to the actual theory of the probability. The theoretical of probability of flipping heads is 50%. So 1 out of 2. Now, let's say the first experiment is 4 out of 6. So we get 40% heads, or 4 out of 10. Okay. Now let's say we keep going. 44 out of 56. Then we get 44%, or 44 out of 100. Now, let's say we keep on going further. Heads ends up becoming 5,067. Tails is 4,933. The probability then becomes even closer to the theoretical one. The experimental becomes closer to the theoretical. 50.67% versus the 50%. And it is a fact, the more you carry out the experiment, the closer that probability will become to its theoretical. It may never actually get there, but it does get closer and closer and closer. The larger the sample size, the larger the numbers, you carry it out. You carry out the experiment. Okay, so that's it for 5.03 notes. If you have any questions, let me know. You have my work number, 469-830-9336. My email, egarzajr@tivahallsville.org. Either one is fine. I prefer email if you, I prefer email. Let me say this. Email me first before texting me or calling me, whichever, doesn't matter. But phones are typically for emergencies if you need answers right now. Otherwise, I'm going to try and get to y'all in a timely manner through the emails. Okay? So if y'all need anything, let me know. Otherwise, that's it for this lesson. See y'all later.